Okay, this is the OCR Foundation paper from 2017, the summer series. This was the one on Thursday, the 25th of May. What I'm going to do is go through the exam paper. I've done some of the workings already to save time. So you can, the best way to use this is to actually have a blank paper in front of you, or even better, a paper you've actually done in a mock. So you can just forward to the questions you want to look at. You don't necessarily have to watch the whole thing all the way through. Question number 1. Measure the size of angle A. Obviously you need a protractor for this. You put your protractor on and you measure it like that. You always start from 0, so measuring from 0 you can see the answer there. I put down 45. I've noticed the mark scheme says 44, but it will allow you a couple of degrees either way. So 44, 45, or maybe even 43 for that one, but 44 or 45 looks pretty good to me. Write down the mathematical name of this type of angle. That is an acute angle because it is less than 90 degrees. Obviously a right angle is 90 degrees, an obtuse angle is between, well, over 90 and less than 180, and a reflex angle are your bigger ones. Choose one of these words to complete the following sentence. These are parallel lines. Parallel lines are lines that will never ever meet. Vertical line, I always think of a vertical drop. That's a vertical line. A horizontal line, you're lying out horizontally, is like that. And perpendicular lines, you'll need to know what perpendicular is. That is when you get two lines that cross at 90 degrees. So it's when two lines cross, like that. Moving on, question number 2. Use one of these symbols to make each statement true. Well, 17.6 is greater than 17.06. So the way I remember it is the fat end of it, if you like. The bigger end of it is aimed towards the bigger number. So that's why it goes that way around, because this number here is bigger. The next one, they are equal. What you need to do is either on your calculator, you can type in 45 divided by 50, which gives you 9/10. I hope you recognise 9/10 is the same as that. Another way of doing it, you can simplify that. What goes into 45 and 50? Well, 5, so it goes into there 9 times, and into that 10 times. So you need to know that 9/10 is 0.9. Think back to your primary school days, that's in the 9 that was in the tenths column. So that's how you do that one. Next one, round 184,329 to the nearest 100. Well, you need to do 184,000, and that 329, well, it's nearer 300 than it is 400, so it rounds off to 300. If it was 350 or greater, it would round to 184,400, but it doesn't. Next one, write 5/8 as a decimal. It's a calculator paper, so I'll show you the quick way of doing this, but you ought to know that 1/8 is 0.125. I hope you know that a quarter is 0.25, so if you half a quarter, you get an eighth. So if you half 0.25, you can get that. So you could work it out by adding up 5 of them, but the easiest way of doing it, because it's a calculator paper, is to type in 5 divided by 8, because that's what that means as a fraction, and you press your SD button on this Casio and you get 0.625. One easy mark. Next one, here is a list of numbers. Write down an even number. Even numbers end with 0, 2, 4, 6 or 8, and there's only one of them, and it is there, it's 42. The square number, what I'd be tempted to do is write down what your square numbers are. So 1 squared is 1, 2 squared, obviously 2 2s are 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, and so on. 9 squared is 81, so that is your square number there. A prime number is a number that only has 2 factors, so that means it only has 2 numbers that go into it. So for example, if we started from the beginning, 1 is not a prime number because it only has 1 factor, only 1 number goes into it. 2 is a prime number because 1 and 2 go into it. 3 is a prime number because 1 and 3 go into it. 4 isn't, because 1, 2 and 4 go into that. 5 is a prime number, 6 isn't, 7 is, 8 no, 9 because 3 3s no, 10 no, 11 yes. So that's how you work out your prime numbers. But the way I did the one above is sort of just by a process of elimination, really. 27, I know 3 goes into that, so that can't be a prime number. That's not, because 7 3s. That one, yeah, it must be. Even numbers greater than 2 aren't prime, because 2 goes into it. That one's going to be prime because nothing goes into it apart from 1 and 23. That one is 3 13s, and that one 5 goes into it 9 times. Next one. Question number 4. Karen she's already done it, made 40 cakes, and she gives 1/5 of them to Andrew. So look what I've done there. 1/5 of 40 is 8. So she's given 8 cakes to Andrew. She then gives 10% to Chris. I don't know why she likes Andrew more than Chris, but there we go. So 10% of 40 is 4 cakes to Chris. So she's given away 12 cakes. So that means she's got 28 cakes left. Let's look at a bit of maths there. And the question says, what fraction of the 40 cakes does she have left? Well, she's got 28 left out of the 40. I always get asked if you should simplify that answer. I'll be really honest with you. Well, in this case, no, because you're not asked to simplify the answer. And in fact, the mark scheme says you have to put this down to start with. And it said if you put that equals whatever and whatever, it says to ignore it. So that is what you need to put down. Question number 5. I'll let you have a brief look at that for a moment. Okay, write down the coordinates of point P. Well, it's along the corridor, then up the stairs, if you remember your stuff from year 7. So along the corridor is 4, up the stairs is 3, so it's 4, 3. Point Q, it's back along the corridor, then down the stairs, so it's -2, -1. And plot point R at 3, -2. So 3 -2, so that's why it goes there. The next one. Draw the line y equals 3 on the grid. I just want to talk about this one for a minute, and then I'll show you what the answer is to it. Whenever you plot a line on a graph, what you're doing is you plot the x-axis first, that's your along the corridor, and then you plot your you plot your x coordinate first, then you plot your y coordinate. So your x coordinate is along the corridor, because it's the x-axis, and your y coordinate is up or down the stairs. So if you don't know how to do this, it's a really simple way. Draw the line y equals 3. Well, for the line y equals 3 to be true, y always must be 3. So I'm going to put in a load of coordinates there where y is 3. You could put in a few more if you wanted, it doesn't matter. Now you can put whatever you want in for x. In this case, I suggest putting it between -3 and 7 so it fits on your grid. So let's just keep it nice and simple. Let's go for 1, 2, 3, 4. And what I'm going to do is plot these coordinates on my grid above, and you'll basically see where the line y equals 3 goes. So I'll do it in red pen so it shows up. You'll do it in pencil. So we're going to plot 1 3 2 3 3 3 4 3. So 1 3 2 3 3 3 and 4 3. There we go. And you get your ruler and you connect those up, and that is the line y equals 3. Next one, question number 6. Work out 17% of 54. Give your answer correct to 1 decimal place. Okay, so 17% as a decimal is 0.17. So all you need to do is multiply 0.17 by 54 and you get 9.18. It does say to 1 decimal place, so you need to round that off to 9.2 because the 8 rounds up the 1. You could do your classic 10%, 5%, 1%, 1%. But this is a much quicker way of doing it, so try and get used to doing it this way. You will get the same answer though. Question 7, simplify. So the simplify is a keyword, it means make simpler. So let's do your t's first. So you've got 7t and adding 5t, so that's where you get your 12t from. The next bit is you've got minus 6u take away 4u. So basically you're doing minus 6 take away 4, which is minus 10. So it's 12t take away 10u. So that's your answer to that one. Next one, it says factorize. First of all, factorize means put into brackets. So what you need to do is what number goes into 5 and 20? What 5 does. So you put a 5 outside your brackets. Are there any letters common? Well, no. So you do 5 and draw your brackets. 5 times what gives you 5v? Well, 5 times v gives you 5v. 5 times 4 will give you the 20, and you need the w there as well. So there's 1 mark. You must know how to factorise that. It's fairly straightforward, that one. Part C, 3 marks for this. Solve by factorising. And they've been quite kind because they have said to solve it by factorising, so that should give you the clue. You need to recognise it's a quadratic one, so you need to factorise it into double brackets. And if you can't remember how to do this, you need 2 numbers that add up to make positive 10 and multiply to make positive 21. So it's all positives, there's nothing too horrible in it. First of all, get your x's in. So x and x. I can tell by looking at this everything's going to be positive, so put my add there and my add there. Right, so I'm after 2 numbers that multiply to make 21 and add up to make 10. Well, there's not a lot that multiplies to make 21. There's obviously 1 and 21. That won't add up to make 10. Or 7 times 3, which does make 21. It also adds up to make 10. So it's x add 7, x add 3. Or x add 3, x add 7. So you'll probably get 2 marks for getting to that stage. To solve it, you need to work out what x has got to be for this bracket to be 0 or for this bracket to be 0. So here x would need to be minus 7, and over here x would need to be minus 3. Just to briefly try and explain that. When you've got double brackets like this, we don't show it, but there's a multiply sign in the middle, and we want the answer to be 0. And the only way of getting something when you multiply to be 0 is to multiply one of the numbers by 0. So if we can make this nothing, this 0, it doesn't matter what this is. It could be 1 million. But if you're timesing it by 0, the answer is going to be 0. So that's why here you need a minus 7, and here you need a minus 3, because this one could be 0 also. Next one, question 8. Apple crumble is used making these ingredients. So I'll let you read it there. By the way, if you ever want to pause during this so you can have a closer look, please do. Right, so we're making apple crumble to serve 12 people. How much flour should he use? Well, for 6 people, it's 120 grams. So for 12 people, you just double it, and it's 240 grams. Just ignore that for a moment. I'll come back to that when I get further down. We're making crumble now for 2 people. How much butter should she use? Well, for 6 people, you want 30 grams of butter. So for 1 person, you need 5 grams of butter. I know that because I've divided the 30 by 6. So for 2 people, it is 10 grams. Hopefully, those 2 are fairly straightforward. Next one, we've got 1.3 kilograms of apples and plenty of the other ingredients. Can we make crumble for 15 people? And the key bit here is explain how you got your answer. It's not an English exam, it's not a history exam. Explaining you can do by writing some numbers down and showing your workings. That's what explain means in maths. Right, so let's have a look. First of all, we need to work out how many apples we need. So up here for 6 of them, 6 people rather, you need 550 grams. So what I've done is worked out enough for 3 people, because I've halved it there, look. So to get 15, you want this 6 person, add this 6 person, add this 3 person, because 6 add 3 gives you 15, and that's exactly what I've done down here. I hope those workings make sense. So 15 people, you need 1,375 grams of apples, or 1.375 kilograms. Don't forget to go from grams to kilograms. The word kilo, I'll write this down, it means 1,000. So whenever you get grams and kilograms, or meters and kilometers, or kilometers, but you know, the kilo means 1,000. So 2 kilograms means 2,000 grams. 1.3 kilograms means 1,300 grams. So I've said that down here. Anyway, basically, no. because she needs 1,375 grams of apples and she's only got 1,300 grams. It's well worth, because look, it's 4 marks, doing a little 1-sentence job at the end just to make sure you're getting those marks. Next one, question 9. It's a pie chart question. Let's have a look. So George has recorded the scores of 120 goals. He started to draw a pie chart. Blah, blah, blah. Okay. How many goals did Simon score? Right, you need to recognise that this is 1/4 of the circle, and the bit that tells us that is a right angle, and obviously, well, hopefully you know that that's 90 degrees, and in a full turn you can get 4 right angles, 4 lots of 90 degrees. So you need to work out 1/4 of 120 goals, which is 30 goals. So Simon got 30 goals. If you want, you can write it in there, 30 goals. Right, the next bit. The table shows the other players who've scored some goals. Complete the table. Right, whenever you do a pie chart question, the first thing you need to write down is this little magic formula here. It's 360 divided by the total, because this will tell us how many degrees each person, or each goal in this case, will get. So for this question, it's 360 divided by the total, which is 120 goals. It said that in the question at the top. So you do that calculation, and that means it is 3 degrees per goal. And you can check that this works, because look, 48 goals times it by 3 will give you 144 degrees. The next one, 5 goals times 3 gives you 15 degrees. The next one here, we didn't know what this number was, we had to work the other way. So if you know the number of degrees but you don't know the number of goals, instead of multiplying by 3 this way, you can divide by 3 going back the other way. So 72 divided by 3 will give you 24. And the last one here, you've got to work out, you've got no data for this, so you've got to work out how many goals Anthony gets. Well, you're told that there's 120 goals in total. You've also worked out that Simon scored 30 of them. So what I've done 120, and I've subtracted the 48, the 5, the 24, and the 30, and that leaves you with 13 goals, which Anthony must have got. And because it's 3 degrees per goal, that'll be 39 degrees. So now you've got your angles, you're in a good position to draw your pie chart, which I'm going to show you how to do in case you're not sure. First bit, Simon is already in there. He's on 90 degrees, so he's happy. Next one is Wayne is 144 degrees. So if you've not done this for a while, you set your protractor up like this. You measure from this angle this line going down. So 144. You start from 0. Don't do what most people do, well, a lot of people do, and go, oh, there's 144 there, I'll do it there. You've got to start measuring from 0. So 0, 10, 20, 30, 40, all the way around to 144 degrees. Put a little line there. And you must do this as you go along. I'm going to write in 144. And I'm going to write in that was Wayne. Looks like he was a top scorer. There we are. The next one is Harry. Maybe he was a defender. He got 5 goals, which is 15 degrees. So we're going to start from here. 15 degrees. Put yes. Then you on. Try and keep it as accurate as you possibly can. Goes without saying. That was 15 degrees, and that was Harry. And there's a couple left. There's Obi, who got 24 goals, and that's 72 degrees. So get your protractor back on. Again, get that in the middle. Measure from 0. 72 degrees is roughly there. That was Obi, wasn't it? And he had 72 degrees. And the last person, Anthony, this hopefully, and you can check this, should be 39. Let's have a look. There you go, just under 40, so that looks close. It's not quite exactly 39 because I might have got each of the others out by 1 degree, but that is certainly close enough. So that is Anthony, and that is 39 degrees. And that is your completed pie chart. Question number 10. The pass mark for a test is 86%. Steve gets 52 out of 61. All I've done there is written it as a fraction. Did he pass the test? Right. 52 over 60 out of 61. That's a divide. So 52 over 61 on your calculator, and that comes out to, oh goodness me, quite a big long number. So let's write that number out. 0.85245901. You could keep going if you want, but for what I want, that's enough. To convert that to a percentage, you multiply it by 100, so that will give you 85.245901, and so on percent. So did Steve pass the test? No, Steve did not pass the test because he needed 86% and he didn't get it. So just write no, Steve did not pass because he should have worked harder, I expect. Yeah, so again, it says explain your answer. Again, it's not a history exam, it's not an English exam. There's your explanation there. Look, you've done your calculations, you've found it as that's a dreadful percentage sign, but you've found it as a percentage. So all is good. Next one. Question 11. 320 people go on a coach trip. Each coach holds 53 people, and Gary says that 6 coaches are needed. Is he correct? Well, Gary says he wants 6 coaches that can hold 53 people, so in total he can hold 318 people. But, and Gary's not realised this, there are 320 people going on the coach trip. So actually, if Gary was left in charge of ordering the transport for it, you would be 2 people would be disappointed. So is Gary correct? No. You can write something like, he is 2 people short, or 2 people would not fit on, something like that. Again, that basically when the examiner marks this sort of thing, if they can see you've written 318 there with a no, they'll probably just give you the 2 marks and move on, because they're the 2 crucial bits of information. Because if you get those 2 bits of information, you can't really get any of it else wrong. Right, next one. Trish and Mark, they're doing a bit of cycling and they've cycled the same distance. Right, what I've done for this one, look, for Trish, I've written out all of her bits and pieces here. There's your speed, distance, time triangle, and it's a speed, distance, time question. So Trish completed the distance in 2 hours. So my time for Trish is 2 hours. Her average speed was 16 miles an hour, 16 miles an hour. And what I've done, look, the distance for Trish, you don't actually need this really. I hope you can recognise that if she's travelling for 2 hours, an average speed of 16 miles per hour, well, in 2 hours she's going to do 2 lots of that 16, so she's going to travel 32 miles. If you don't like that, you want to work out distance, well, to do that, you cover up your D on your triangle, and distance is speed times time. So 2 times 16 is 32. And I've worked that out because it says they both cycle the same distance. So Mark has cycled 32 miles as well. Mark completed the distance in 4 hours. So what you need to do now is work out the time. Oh, excuse me. So speed, again, if you want to work out the speed, you cover it up. Speed is distance divided by time. So that will be 32 divided by 4, which would be 8 miles per hour. There are other ways of doing this question. To be really honest, if you can notice Trish completed the distance in half the time it took Mark, so it's fairly safe to assume that Mark was going at half the speed that Trish was. But if you don't like it like that, you can work it out properly like this. Okay, question 13. The ratio 20 minutes to 1 hour can be written in the form of 1 to n. Let's have a look. Find the value of n. So it's a ratio question. So what I would do, and you need to sort of recognize this fairly quickly, is that if you're doing something in the ratio of 20 minutes to 1 hour, you need to convert the hour to minutes. So I've done 20 to 60. I've simplified that ratio to 1 to 3. You could go 10 to 30, then 1 to 3, but you get to the same answer. So it can be written in the form 1 to n being 3. So the answer is 3 for 1 mark. Part B to that. The scale on a map is 1 to 25,000. An important thing to realise here is that it doesn't matter what the units are here, but they must be the same. So for example, if it's 1 centimetre on a map, it's 25,000 centimetres in real life. If it's 1 metre on the map, it's 25,000 metres or 25 kilometres in real life. So the units must be the same. Doesn't matter what they are, but it's got to be the same. In this case, because they're talking about centimetres, I'd be tempted to say, use centimetres. So 1 centimetre is 25,000 centimetres. So 6 centimetres, because I've multiplied by 6, must be 150,000 centimetres. So that's pretty much your answer, but it does say give it in kilometres. So what I've done is converted it to metres, and you need to know there's 100 centimetres in a metre, so I've divided by 100, and then I've converted from metres to kilometres by dividing by 1,000. Don't forget, as we mentioned earlier, kilo means 1,000, so kilogram, 1,000 grams, kilometre or kilometre, 1,000 metres. So the answer is 1.5 or 1.5. Part C, Kiri and Peter share some sweets in the ratio 6 to 7, or 6 parts to 7 parts. Whenever I see a ratio question, I always put their names at the top. And if it says Kiri and Peter, that means the 6 to 7 must be Kiri and Peter as well. What fraction of the sweets does Kiri receive? Well, she gets 6 parts, and there are 13 parts in total. So she gets 6/13 of the total number of sweets. A common mistake for that is to put 6 over 7, but don't forget the denominator, or the bottom number, but we say the denominator represents the total number there are. So the total number of sweets are 13, and Kiri has 6 of them. Question number 14. Write 543,000 in standard form. To put a number into standard form, the first bit must be a number between 1 and up to, but not including 10. Then you write times 10 to the power, and that's the next bit. So it's going to be 5.43, because that's between 1 and 10. So there's my 5.43. And you see how many places you have to move the decimal point, which is 1, 2, 3, 4, 5. So it's 5.43 times 10 to the power 5. A common mistake is to see there is 3 zeros, so put it to the power times 10 to the power 3. It's not that, it's how many times you move that decimal point. Part B, write 6.3 times 10 to the minus 2 as an ordinary number. Well, I've written it here in red, 6.3 times 10 to the minus 2. Because it's to the minus 2, that tells you the decimal point is going to move the other way, or the way I used to remember it when I was at school. It means it's going to be quite a small number. So we're going to move the decimal point 2 spaces this way to make it smaller, and you see I've done that. So the answer will be 0.063. So 0.063. Next one, Pierre is given the question. Work out 61,000 times 4,000 and give your answer in standard form. Pierre's answer is 24.4 times 10 to the power 7. Is Pierre correct? And the key word there is explain your answer. So explain. What I did was I worked it out. It's a calculator paper, so I did 61,000 times 4,000, which gave me this number here. And then I converted this into standard form. So you move the decimal. So it's 2.44 times 10 to the power 1, 2, 3, 4, 5, 6, 7, 8. So that is the correct answer. And what you should be able to spot, what Pierre's done, he's put 24.4, and it's incorrect because this number here needs to be between 1 and 10, and it is not. So if he'd done 2.44 times 10 to the power 8, it would have been correct. So to answer this question for 1 mark, show the correct answer and then just write one sentence saying that this number here, point an arrow to it if you want, needs to be between 1 and 10. Question number 15. Mr. and Mrs. Thomas buy tickets for themselves and their 4 children. The cost of an adult ticket is £7 more than the cost of a child ticket, and the total cost of the 6 tickets is £86. Right, there's a lot of information there. So what I started to work out was how many tickets they're actually getting. And because it's Mr. and Mrs. Thomas, that's 2 adults. I'm guessing that's adults because they've got children. And it says 4 children. And the total cost is £86. There are a few ways of answering this, but I'm going to use algebra because I think it's the most logical way. So if we assume a child ticket is X, that means an adult ticket must be X add 7 because it is £7 more. So that means 4 child tickets would be 4X, and we want 4 child tickets because there's 4 children, and 2 adult tickets must be twice the amount of this. So it's 2X add 14, which is what I've got here. So all of this will cost £86. So we've got 6 X's, add 14 equals £86. Now that's an equation which you can solve. It's relatively straightforward. You want to get rid of this 14. How do you get rid of that? Well, you subtract 14 from both sides, and I hope you can see I've done that. And then you've got, so 6 X's are 72, divide by 6, and you'll be left with X equals 12. And don't forget, X was a child ticket. For an adult ticket, we must add on £7. So 12 add 7 gives us the 19, because the question was, what is the cost of an adult ticket? I'll leave that there so you can see my workings. You can just pause that if you want to have a more of a look through what I've done. Question 16. Okay, scale drawings here, and this is a slightly tricky one, but we're going to go through it together. First of all, I wish I hadn't done this before, but I'm going to actually do it as if I'm doing the question again. So it shows the positions of town A, which is over here, and town B, which is up here. It says Lucy's house is nearer to town A than to town B. So basically her house is nearer to this town than it is to that town. And to work out that, you need to draw something called a perpendicular bisector. And I'm going to show you how I've done my perpendicular bisector here, which is that line there that goes right between them. So anything this side is closer to A, anything that side is closer to B. What you do is you get a set of compasses like this, or a compass as I call it, but a set of compasses, and you put your point on B or A, you can start with, and you've got to stretch it out so it's more than halfway. It doesn't matter how far you stretch it out. I'm just copying what I've done before. So you do a little sort of swoosh there, and you do a swoosh down here as well. So I hope you can see the 2 swooshes I've done. And then you do the same thing for A. Keep the compass the same distance. That's really important. So that's where that line comes from there. And down here, you can hopefully see where this line comes from here. So what you end up with is where they cross there and where they cross here. And you need to get a ruler. And then you just connect them up like that. And you draw that line on with a pencil. And that is your perpendicular bisector. You'll probably get, if it's 5 marks for the question, you'll get 2 marks for that. The next thing, it says her house is exactly 50 miles from town B. So here's town B. We've got a scale, and that says 1 centimetre is 10 miles. So if it's 50 miles from town B, 50 miles is going to be 5 centimetres. So you need to get a ruler, and then you get your compass, and you measure out 5 centimetres like this. So make it a little bit smaller, and hopefully you can see the distance there is 5 centimetres. What you do then is you place it on B, and then you do this great big arc you can see around there. So that is me doing that arc there. On the diagram, you must show all the possible locations of Lucy's house. So Lucy's house is closer to closer to town A, sorry. So that means it is below or to the left of the line or below the line. So it's this side of the line. And because it's exactly 50 miles from town B, it can be anywhere along this line here. Absolutely anywhere along that line, because all these points along this line are closer to A than they are to B. And they're also exactly 50 miles from B. So start from there and you curve round and you get to there. And what I've done, I've drawn a little arrow showing where all the possible locations of Lucy's house are. I've even gone over this in slightly thicker pencil, just to make it really clear where I'm showing what my answer is. The next key bit is you must show all of your construction lines, and your construction lines are these lines here that you use to draw your perpendicular bisector, and it is also this arc you've drawn here as well. Don't try and do this question by just having a guess, because you won't get any marks. You must show these construction lines. If you don't know how to draw a perpendicular bisector, go on Google or YouTube and have a look, or please ask your teacher. I guarantee it will come up in one of your exams and it's worth 2 marks. So you need to know how to draw a perpendicular bisector. Next one, question 17. It's over the page. Let's have a look. Right, this one here. At the start of 2014, Priya's house was worth £240,000. The value of her house increased by 5% every year. Work out the value of her house at the start of 2017. First thing I did is 2014 to 2017 is 3 years later. So you need to increase this by 5%. Get a figure, increase it by 5% again, get a figure, and increase it by 5% again, get a figure. But the easier way of doing it is recognizing that 5% as a decimal is 0.05. You should have learned or should have been taught how to increase by a percentage using the multiplier method. So to keep 240,000 the same, you multiply it by 1. And because we're increasing by 5%, we add on 0.05, which remember was 5% as a decimal. So once you add those two up, you get 1.05. So you can do 240,000 times 1.05. If you just times it by 1.05, you'll increase it by 5%. If you want to do that for 3 years, you put it to the power 3. And that will give you your answer there, 277,830. Another way of doing this bit, and some people like to do it, is they do 100% and they add on 5%. So that gives you 105%, and then they convert that to a decimal, which is 1.05. Obviously, your multiplier you're getting is the same as the method I've used. So there are 2 ways of doing that question. Next one, right. Sorry, just got cut off there. As I was saying, question 18, this is sometimes also known as prime factor decomposition. Right, the next one, buses to, looks like Ayton to me, leave the station every 25 minutes. Hopefully you've done so many of these past papers, you know exactly what question they're about to ask. Buses to Bleaford leave the station every 40 minutes. Buses to both places leave at 9 a.m. What is the next time the buses leave the station together? So, they both leave at 9 a.m. and at Ayton it's every 25 minutes. So the bus goes at 9 o'clock, 9:25, 9:50, 10:15, 10:40, because I'm adding on 25 minutes each time. And at Bleaford they go every 40 minutes. So they leave at 9 a.m, 9:40, 10:20, 11 o'clock, 11:40. And you keep going down until you find a time when they leave the station together again. And in this case, that time is 12:20. That's possibly the easiest 4 marks on the paper. So if you know what you're doing there, just get on with it and get your numbers in. All right, do come back and double check it, because I don't want you losing any simple things on that. Next one, question 18. Here we go. Right, probability trees. Oh, hang on a minute. well, that's 0.3. I reckon that's going to be 0.7, but I will read the question. Kirsty either travels by bus or walks when she visits the shop. So she never ever takes her bike or jogs or gets a lift. She always goes by bus or always walks. So if the probability of her taking a bus is 0.3, the probability of her walking must be 0.7, because it has to add up to 1. She either buses or she walks. The probability she catches the bus from the shops is 0.8. So I'm guessing this is going home. She's much more likely to catch the bus going home. Maybe she lives at the top of a hill, who can tell. But we'll put in 0.8 for that. So that means the probability she walks home must be 0.2. So bus home is 0.8 and walks home is 0.2. Right. Complete the tree diagram. We've just done that. Show the probability that Kirsty walks at least one way is 0.76. Right, there's a quick way of doing this, but I'll show you the full way first of all. What I recommend you do is at the end of each of these, you work out the probability. So this might learn something, but probability, for example, probability she'll take the bus to the shops and home again. We can call that bus if we want. Is 0.3 times 0.8. So 0.3 times 0.8, which will be 0.24. So 0.24 is the probability she catches the bus both ways. The probability she catches the bus then walks, so bus then walk, is 0.3 times 0.2, which would be 0.06, I think. The probability she walks then gets the bus, so walks and gets the bus, it's looking the most likely because it's 0.7 times 0.8, so 7/8 of 56, so that'd be 0.56, and the last one is walk both ways, so it's 0.7 times 0.2, which is 0.14. Right, all of these ones I've just worked out now, that and that must add up to 1, because it's, there's no other ways she can go to the shops and home from the shops. I've got all the combinations there. Show the probability that Kirsty walks at least one way is 0.78. So walking at least one way is this one, and this one. So what you need to do is show these workings here, then you need to show that you've done 0.06, add 0.56, add 0.14, and you add those up and you get 0.76. So you need to show that calculation. For those of you who are quite proficient at these things, you could have spotted, you could have done 1 subtract 0.24, and that is also a fine way of working it out, but this one is probably a little bit simpler, but either way you get the right answer. Next one, question number 20. Mo's tyre pressure gauge shows a reading which is 12% higher than the actual pressure. Basically it's broken and it's reading too high. So give you an example. So if his tyre gauge pressure said 112, the actual pressure would be 100. So what is the actual pressure when Mo's gauge shows 38.64? Well, don't forget 38.64 is too high. His tyre pressure is not that much, because that is actually 12% higher than what it should be. This is a reverse percentage question, and the way I tend to work them out is by knowing that figure there, because it's 12% higher than what it should be, is actually equal to 112%. And you need to work out what 100% is. So what I'm going to do to both sides, I'm going to divide it by 112, because that will tell me how much 1% is going to be. So I need to do 38.64 divided by 112, That will give me 0.345. Then to get to 100%, which is what I want, I multiply by 100. And that is 34.5 equals 100%. So the actual pressure is 34.5. Again, that's a reverse percentage questions. You work pretty much all of them out that way. You just need to recognise that if it's 12% higher, it is 112% of it. Then you need to get it down to 1%, then up to 100%. Question 21. The diagram shows a semicircle inside a rectangle of length 120 meters. So that's 120 along there. The semicircle touches the rectangle at A, B and C. What that is just telling you, it's hitting the edges. Calculate the perimeter of the shaded region. So it wants to know that length, add that length, add that length there. First of all, and I've actually done this at the bottom, because it's a semicircle, I'll split that down there, look. You should be able to spot that that length there is 60 degrees. And now because that's a quarter of a circle, and that length is 60 meters, and this length is 60 meters as well. But anyway, let's get into it. I'll try and explain what I've done. So first of all, the circumference of a full circle. So let's pretend this is a full circle all the way around. The circumference of a circle is pi times the diameter. So in this case, it is pi multiplied by 120. You see my workings here, which is 376.99 and so on, or it might say 120 pi. But I don't want the whole circumference, I just want this bit here. So basically I want 1/4 of it. So to find a quarter of it, I've divided by 4, which gives me 94.24 and so on, or 30 pi. So I've got that bit, then I want to add on this bit, and that is 60, and you see I've added it there, and then I want to add on this bit, which is also 60, so I've added it on again. The answer is 214.2477796. But it says give your answer correct to 3 significant figures. If you're not sure about how to revise significant figures, please go and see your teacher or have a look it up on the internet. But it's basically 214. Right, will that 2 round up that? 4? No. So the answer is 214. And the units are already down the bottom. I'll leave that there. There's my workings for it. It is 5 marks. Basically, circumference of a circle. You need to be getting some of this stuff out and working some bits and pieces out to get some marks. Question 22. Here we go. Right, this bearings one. It's a really fiddly one, but I'll talk you through it best we can. A, B, C and D are 4 tells. It says B is 25 kilometers due east of A, so that's that. C is 25 kilometers due north of A, and D is 45 kilometers due south of A. Work out the bearing of B from C. So basically you're coming from here, you're going this way. So what I'm going to do is actually draw that on. I'll get my pencil and my ruler. So we want to know this bearing here. And I'll draw my north line on as well, so you can actually see the angle I'm trying to work out. Right, so you want to work out that angle there. When you're answering this one, what you need to spot is that the distance here and the distance here are equal. I know it doesn't look like it, but it says they're both 25. So if they're both 25, it actually makes that triangle an isosceles triangle. There. And because those two are the same length, it means that these two angles at the end are also going to be the same. So that angle there has got to be 45. And the reason I'm saying this is because that is a right angle, so that's 90 degrees. And for these two to be the same, there's 90 degrees left over, so they both must be 45 and 45. So this angle in here, obviously there's 180 degrees on a straight line, and if that angle there is 45, you do 180, take away 45 degrees, and that will give you 135 degrees. So that is your bearing there. 135. Just really fiddly, really horrible, but if you spot it, well done, that's great. Next one, calculate the bearing of D from B. So D is down here and B is there. So D from B. So what I've done, I've drawn this triangle out, the ABD one down here, ABD, and you're trying to work out the bearing of D from B. So if you imagine there was a line going up there, we are looking for that angle there. This is 4 marks, it gets really fiddly. If you don't like trigonometry, I suggest you just pause it and move on, but we will go through it. Right, basically you need to work out either that angle there or that angle there. I'm going to work out, it really doesn't matter which one you work out, to be honest with you, but I'm going to work out, let's work out this one here. And I'll tell you what, because once you work one of them out, you can work the other one out, so it's fairly straightforward. So we're going to find a missing angle. We're going to use trigonometry. So this is what you've got to remember of it. Is it sine or sin, cos or tan, or sine, cosine and tangent? Right, label your sides. There's your hypotenuse, that's your long side. This is one here is opposite the angle, and that one is adjacent to the angle, so adjacent. So which one of your ratios, sine, cos, or tan? It's tan has got the opposite and adjacent in. So we're going to use tan. So tan x equals opposite over adjacent. So tan x equals 45 over 25. So angle x, you put that in your calculator. Don't forget to use the shift or the inverse, depending on what you do. On these Casios, you've got to use shift, so that's not showing up massively well, but shift tan 45 over 25. I always close the brackets, don't know why. And that will give you 60.945. It does go on, but I'm just going to use 60.945 for the time being. So 60.945. I put 60.9 in there. So from that you could work out this angle if you wanted, but really, and this is why I'm going to start breaking down this triangle a bit, the angle you are after is this one in here, because you know that is 180, so you need to work out this one, and because that's going to be a right angle, you can work that angle out there by doing 90 take away 60.945. So I'll write that down. So 90 take away, you see that? 60.945, and that will give you that angle up there, and that is 29.055. 29.055 in there. So the answer is 180 add 29.055. So you do that, 180 add 29.055. That will give you 209.055. And the mark scheme says it wants a, because it's a horrible angle, I don't know why they didn't round it off to so nice one, but the mark scheme says the answer has got to be, and I've written this down here, look, between those two. So it's got to be from 209 to 209.1, which obviously mine is. So yeah, so that can be your answer. It's really horrible, really fiddly, really nasty. But if you're good at trigonometry and you're pretty good at bearings, it's worth having a shot. Alright, we're getting near the end now, just 2 more questions to go. So Next one. The table shows the average number of customers per day entering a shop. So that's in 2015 and that's in 2016. Complete the time series graph below. Well, I've already done it, but I'll show you how I've done it. So all these ones are done for you. Next one. January to March. So January to March in 2016 is 130. So you mark an X there. From April to June it is 304, so April to June is 304. July to September is 381, which is 381, and October to December is 192, and so on. So there we go, and you just connect those up with a ruler, 2 marks, pretty straightforward, especially if one of the questions at the end. Now, this is the number of customers per day entering a shop. So it's an average, isn't it? So basically, let's look at the first one. So on average, in 2015, from January through January, February, and in March, on average per day, they had 119 people going through the door. And the next bit of the question says, make 2 different comments comparing the number of customers entering the shop in 2015 compared to in 2016. Well, I'll be honest, there's loads of things you could write, but what I've just written down here are some notes from the mark scheme about the sorts of things it is after. So what you could have done, you could have compared the total number of shoppers from 2015 to 2016 for 1 mark. So you could have added up all of those ones, then added up those ones, and compared which year got the most number of shoppers. Fairly straightforward. You could have compared seasons in 2015 with 2016. So, for example, you could have said in the summer months in July 2015, they got less shoppers than they did in July in the summer months of 2016. So you could compare individual seasons like that. If you do compare them, please use actual numbers from the graph, and maybe even say that in this year they got, is it 13 more or something in that month? Or the next one you could do, you could compare seasons in the same year. For example, there were more shoppers in the summer months. So you could have said there's more shoppers in 2016, there are more shoppers in the summer months than there were in the winter months. I suppose you could assume from that they're selling summer themed things, whatever that is, buckets and spades or something. Because usually you'd think around Christmas people go and buy a lot of tat and stuff for their loved ones, don't they? But anyway, it's not asking about that. There we go. So yeah, make sure you quote figures. You need to get down 2 of those, and there. So basically, any 2 comments from those ones. Do not compare 2 things from the same category. So do not say, oh, in 2015 compared to 2016. Don't compare the first month, first 3 months, and then the next with each other, and then the summer months with each other, because it will class that as the same sort of thing. Right, last question. Right, this is going to be a simultaneous equation. Each week Dan drives 2 routes, and he's creatively called them X and Y. That's handy for you, because you should be spotting if he's got X and Y in the question. It's algebra to solve it. 1 week he drives route X 3 times and route Y twice. And he drives a total of 134 miles. So he drives 3 lots of X and 2 lots of Y, and that's 134 miles. See what I did there? Next bit, he drives route X twice and route Y 5 times. So X twice, route Y 5 times, and it has a total of 203 miles. Find the length of each route. This is called solving a simultaneous equation. If you don't know how to solve a simultaneous equation, you need to go and ask your teacher or look it up on the internet or something. I'm going to go through it with you now, but I'm just literally going to go through it quite quickly. Right, so to solve this, you need to get either your values of X or your values of Y the same. So you could get the X's to 6, or you could get the Y's to 10. I'm going to get the Y's to 10, just because I feel like it. So first, to get this to be 10Y, we need to multiply everything by 5. So you're going to multiply everything on that top row by 5. So that's going to make that 15x. Add 10y equals, and I've got to do 134 times 5, which is 670. Right, and because I've multiplied everything by 5, that's fine. Here I've got to multiply everything by, well, I've got to get that to be 10y, so by 2. So that's going to become 4x, add 10y, equals 406. So once you've got this now, we've got the y's the same, we need to get rid of them. So how do you get rid of a 10 and a 10? Well, if you add them up, you get 20. So you need to subtract them from each other. So we're going to subtract everything here. So 15x, take 4x, will give you 11x. The y's cancel. And then you're going to do 670, take away 406. I'm just double checking that, is 264. So 11 lots of x is 264. So let's divide both sides by 11. So x is divided by 11 is 24. And don't forget we're dealing in distances, but we'll sort that out at the end. So x is 24. We know that, we're fairly confident. Lost my red pen. Oh, here it is. Right, so to work out y, we've got to substitute this back into the original equation. So you can choose either one. I'm going to choose the top one. So 3 lots of x, add 2 lots of y is 134. Well, we now know x is 24. So 3 lots of 24 is 72. So you've got 72, add something, gives you 134. So you need to work out what that something is. So we're going to do 134, take away the 72, and that will leave us with 62 in there. So 2y is 62. So 2y is 62, 1y will be 31. So 1y is 31, and that is the answer. X is 24 and y is 31. If you wanted, you could multiply these up by the given figures here to make sure they work, but I'm sure they do. The very last bit is only 1 mark. State an assumption that has been made in answering part A. I'd say something along the lines of when he took the routes, there weren't any diversions set up, and he followed the same route every time. So for example, route X, he's got to make sure he follows exactly the same route with route X. There's no point one day going via the back lanes, the other route going the main road. He's got to go the same distance each time. So the assumption is he followed the same routes each time. Right, that's the end of it. Paper 1. Obviously there's 3 papers now with the new GCSEs. I don't like giving out marks about grade boundaries and things. If you're looking to get a 4, which is it's equivalent to a C, it is a pass. It means you don't have to do it again next year. I'd be aiming to get about 50%. I think recently it has been as low as sort of mid-40s, but aim to be